Improving recommender system via personalized reconstruction of reviews. What is personalized review document reconstruction, and what is its purpose? The purpose of personalized refactoring of review documents is to capture vocabulary that is very useful to users and items, and to form new personalized review documents so that we can more fully capture the granular features of users and items. For example, under the same item, there are many historical reviews. By personalizing these reviews, we can obtain very brief and useful review texts that maintain the word order. For example, from the first review, we can get good collection of well-known songs but have a minor defect. From the second review, we can get partially damaged sound source, and from the third review we can get very good quality and delivery time. In addition, some reviews may not have any useful information. Since the review information contains rich information that can describe the characteristics of products and users, in order to better make personalized recommendations to users, researchers introduce review information into the recommendation system. The existing review-based recommendation system is mainly divided into three methods. The first is directly based on user and item divided reviews as input. The second is based on user and item review documents as input. And the third is take the divided review and the review document as input at the same time. Compared with other recommendation systems, we take user and item divided reviews as input, then personalize the reconstruction of the review document, and finally combine divided reviews and personalized review documents to make the final score prediction. There are many recommendation systems based on review documents, but the way their review documents are constructed is static and non-personalized. Because the review documents of these systems are all realized through external data preprocessing, they are not personalized based on the corresponding goals, and their review documents are constructed mainly by connecting each review to form a long review document. A certain length of interception is performed to obtain part of the review document. The second method is to directly select the highly weighted vocabulary in each review and combine it into a review document through the TF-IDF technology. Compared with other models, our model mainly has the following contributions. First, we propose a neural recommendation model that reconstructs reviews into personalized documents and extracts coarse-grained features of users and items by modeling the semantic of personalized documents. To the best of our knowledge, we are the first to build personalized review documents for the recommender system. Second, we propose a cross-attention mechanism to identify important words for personalized document construction. Personalization is achieved by obtaining in-depth word-level interaction features and context-aware interaction features. We design a novel transformer mechanism to learn the interaction feature representation between user-item pairs. We first present our proposed method recommendation with personalized reconstruction of reviews (PPRR) in abstract. The model has three stages: Review Document Reconstruction Network, ReDoc.Net, Document Level Compiler, DocNet, and Review Level Compiler, ReviewNet. The interactive attention characteristics of users and items are captured from word level and review level respectively. The proposed PPRR model has three main stages: dynamically selecting informative words by cross-attention to build compressed personalized documents of users and items, encoding the compressed personalized documents with convolutional neural network layer, and involving the review-level features into document-level representation. How do we get the representation of the vector of reviews? In order to better learn the features of users and items, we label each review with ID. We label all the words that appear in the reviews, and then construct the digital reviews through the correspondence between the words and the labels, and finally construct the initial vector representation of the reviews through the word embedding layer and the pre-trained 300-dimensional word vector of Google News. In addition, we also obtain the initial vector representation of each review ID through the ID embedding layer. How to reconstruct the personalized review document? We firstly design a personalized document builder to dynamically extract the most informative words in reviews. The informative words are personalized identified according to the semantic relation between certain users and items. That is, given a pair of users and items, we identify the words in the item's texts that are more relevant to the user and vice versa. A cross-attention model is designed to make the personalized identification of informative words. Afterwards, the extracted informative words are organized into compressed personalized documents keeping their order in original reviews, which avoids the disadvantage of bag of words. How to obtain powerful vocabulary? After the embedding layer and the convolutional layer, we get the feature vectors of all IDs and the semantic features of all words. For the same user, the importance of words in different item reviews is different. Therefore, in order to capture the importance of words in different contexts, that is, contextual semantic features, we introduce the ID embedding of the target item, generate word-level cross-attention query vectors through a multi-layer perceptron (MLP), and then capture through crossover attention mechanism and softmax are used to determine the importance of words. How to build a review document? When we obtain the weight of each word in the review, we select the T-words with the highest weight by selecting top T layer, and then use the rank layer and word selector layer to find the original order of the words according to the original subscripts of the T-words and rebuild the orderly review document. For example, the top 3 words with the highest weight of "I love it, it has good quality" are quality love good, but the composed document loses the word order, so we get the word order through the rank layer and word selector layer. And the final review document is love good quality. How to extract user and item features at the document level? For obtaining compressed personalized documents, we design a document encoder to learn document-level semantic representations of users and items. We use a crossover transformer mechanism to involve the contextual characteristics of the document and the characteristics of each word. Finally, we learn the document-level semantic representation of the document through the CNN layer. Among them, in order to further obtain user-item complex interaction features and contextual information, we integrate ID embedding information and word position embedding information into each word embedding, and then use the transformer to capture the interaction features at the word level. The cross-transformer mechanism is based on the in-depth interaction between words, so that each word in the user review document can contain the characteristics and context characteristics of each word in the target review document, and vice versa. How to extract user and item features at the review level. As supplement, we also involve a parallel review encoder to learn the review-level features of users and items. At the review level, we learn the feature representation of each review through the weight of each word obtained by the previous cross-attention model. Then the review feature is used as the query vector, and the review ID vector of the user and the item is introduced to model the quality of each review, and the weight of each review is obtained through the cross-attention mechanism. Finally, the user commodity feature vector representation based on the individual reviews is obtained by the weighted summation of all reviews. How to predict the user's rating of the item in the end. Finally, we fuse document-level and review-level semantic features and ID embedding features that can represent user-item identity information, and then use latent factor model (PFM) to obtain the final comprehensive representations of users and items for rating score prediction in recommendation. In order to prove the effectiveness of our method, we selected real datasets of 3 fields of digital music, office products, and tools improvement from Amazon core datasets as the data for our experiment. These datasets contain the actual ratings, 1 to 5, and review texts made by users on the items. For evaluation, for each data set, we randomly split 80% of the data as the training set and 10% as the validation set and test set, where the validation set for hyperparameter validation. We ensure that the training set contains at least one user-item interaction, and does not contain any reviews in the validation set and test set. For the task of rating score prediction in this work, we utilize the well-known mean square error (MSE) as the evaluation metric. Lower MSE indicates the predicted rating is closer to the ground truth rating. Comparison with each baseline method on MSE. Experimental results on 3 real-world datasets show that our model is more accurate in predicting users' rating scores than best-performing baselines. In this article, we propose a neural recommendation model that can reconstruct reviews into personalized documents and integrate review-level features. In the reconstructed document, we represent the personalized semantic of the reviews of a certain user towards a certain item and vice versa by modeling the personalized importance of each word in the reviews. We propose a cross-transform mechanism to achieve the personalized importance calculating by integrating contextual semantic features of each word. Experimental results on 3 Amazon public datasets show that the proposed model can effectively improve recommendation performance compared with state-of-the-art baselines. And the reconstruction of personalized documents of reviews is verified to be the essential advantage of the proposed model. At this point, my sharing is over. Thank you.